Hi everyone, bonjour. Welcome to my YouTube channel. The IB Crocodile is here. I provide supporting videos for both IB math and physics after 25 plus years of tutoring experience. Recently, I started a series called Nasty Integrals, where I go over certain interesting integration problems. I'm going to place a link to the previous video, Nasty Integrals Part 1. And today's lecture is Nasty Integrals Part 2. So pick your pencils or tablets and let's have fun. The first integral I would like to go through today is the integration of sine squared of x dx. But before to show you how to approach this integration, I would like to step back and share with you a similar one to see really the big difference. So if you had sine squared x, or sine to the power of 2, right, of x dx, but then inside the integration, we have also cosine x. So what is really the difference? If I have cosine x inside the integration, that means I have the derivative of sine itself. Okay, so the way actually to look at this, is basically we have sine x all to the power of 2 multiplied by cosine x dx, right? Where this term here is the derivative of sine. In this case, by inspection, you can just apply the power rule, and this is very easy integration. Okay, or you can use substitution if you like, right? You can use, let's say, okay, let u, if you feel more comfortable with substitution, you can say let u equal to sine x, right? So then du is going to be cosine x dx. So back to the integration. So it's going to be the integration of u squared du, right? Because we have the derivative of the main function inside the integral, right? But then here it would be very challenging because we don't have the cosine x inside. So what to do, right? We cannot integrate sine squared unless you have the derivative of sine inside the integration. So then here, the integration of u squared du, what you do, the power rule, so you add 1 to the power and divide by the new power. So it's going to be u to the power of 3 over 3 plus c, and then you put u back by its substitution, which is sine. So at the end of the day, is going to be 1 over 3 sine to the power of 3, right, of x. That's it, plus c, the constant of integration. So what to do now? What to do to approach this sine squared? So this is a typical approach, sine squared x. Now, if you look at your formula booklet for math analysis and approaches IB, topic 3, trigonometry, you see a couple or bunch, maybe 3 formulas for cosine double angle identities. And this is really the approach, what you're going to do. Some manipulation, right, in order to get a form or a function that I can integrate, right? So, okay, so if you look at your formula booklet, you say cosine 2x, there is 3 formulas for cosine double angle identity. Okay, I'm going to take the one with sine because I have sine here. So 1 minus 2 sine squared of x. And then let's bring sine squared the subject. Okay, so we can bring this to that side with positive, and you can bring that one to the other side with negative. So 2 sine squared of x is equal to 1 minus cosine 2x, right? And then sine squared x is going to be divided by 2, like 1/2 multiplied by all of this. And this is really the approach for that question here for the integration. So let's do that. Let's see what will happen. So this integration here is going to be the integration. Okay, I will take 1/2 outside. If you have a constant, you take it out. So 1/2 the integration of 1 minus cosine 2x dx now became really simpler integral, or you can integrate that, right? So let's integrate. So the cosine of one, sorry, the integration of 1 is going to be x, right? And integration of a cosine, so integration, the derivative of sine is cosine. So integration of cosine is just sine. So basically sine 2x, but then you have to divide by 2, which is the coefficient of x. Right? So you always in integration, you divide by the coefficient of the angle right after you do the integration, and and then you just add a constant. So you can just simplify that. So it's going to be 1/2 times x, right, minus 1/4 sine 2x plus c, and that's it. So this is how to approach sine squared. The same way cosine squared, for example. So the next integration here is the integration of sine to the power of 4x. Okay. So again, you don't have the derivative of sine inside the integral. So you need to think of one of the manipulation of the trigonometry, which is basically using cosine double angle identity as I just showed you. Okay, but here we have basically the integration. We can rewrite this as sine squared of x, right, all to the power of 2, right? Because we can deal with sine squared. And then sine squared x, we can use cosine double angle identity, as I did in the previous example here, and we can replace it by 1/2 multiplied by 1 minus cosine 2x. Okay, so it's going to be 1/2 multiplied by 1 minus cosine 2x, but then that is all to the power of 2 dx, and that's the integration. Okay, 1/2 power 2 is basically 1/4. So you can take 1/4 out if you like, and then the integration now is going to be 1 minus cosine 2x all to the power of 2. Now that is square of binomial. So square of binomial, square of the first term, square of the second term, which is cosine squared of 2x, and then double, and then twice the product of first and second term. So minus 2 times 1 times cosine 2x. Right? So I just expand, this bracket here, all to the power of 2. And 1/2 power 2, I took it out as 1/4. And then, of course, all of this multiplied by dx. You can split integration by on negative and plus, so we can deal with each term, separated by minus or plus, separately. So we can say, okay, so we have 1/4, the integration of 1 dx, for example. So this is the first term, which is easy, very straightforward, right? And then minus, okay, 2/4, I will just take 2/4 out, and then the integration of cosine 2x, again, not too bad. Integration of cosine 2x, we know how to do that, right? And then plus 1/4 again, because it is multiplied out anyway. Now the integration of cosine squared of 2x dx. Okay. So now we need to deal with cosine squared 2x dx, and let's see how we can approach this. Okay. So what we can say cosine 2 theta. So again, I'm going to use double angle identity. So cosine 2 theta is going to be, okay, one of the forms, 2 cosine squared theta minus 1. You can look at your booklet here, table topic 3, right? And you will see exactly this formula here, 3.6. 3.6 in the formula booklet for analysis and approaches. Okay, so cosine 2 theta is equal to 2 cosine squared theta minus 1 meaning that 2 cosine squared theta is going to be 1 plus cosine 2 theta, right? I'll just bring this -1 to that side. So then cosine squared theta is going to be 1/2 multiplied by 1 plus cosine 2 theta. Okay? So now compare this with that. We have cosine squared. Now theta is 2x. Theta here is 2x. So here is going to be 1/2 multiplied by 1 plus cosine 2 theta, which is 2 multiplied by 2x, which is 4x. So let's continue. So I can right away implement the integration of 1/4 times 1. So basically it's going to be 1/4x, right? And then here we have 1/2. The integration of cosine is sine. So it's going to be sine 2x, but then you have to divide by the coefficient, because you have a coefficient here too, not just cosine x. Okay? If it was just cosine x, integration of cosine x is just sine x. But if you have a coefficient, you always divide by the coefficient of the angle. Now, 1/4 multiplied by the integration of cosine squared 2x. Now this guy here is going to be 1/2. So I'm going to put 1/2 outside. And then 1 plus cosine. Now 2 theta, again, as I said, is going to be 4x because 2 theta, right? And this will be just multiplied by dx. Okay, so it's going to be, now we have 1/4x minus 1/4 sine 2x, right? Plus 1/8, and integration of 1 is going to be x, right? And then plus 1/8 multiplied by the integration of cosine, which is sine 4x, but then you need to divide by 4, again by the coefficient of x, and then plus c. Okay, if you really want to simplify, so just multiply 8 times 4 will be 32, right? So now the end, or the final answer, 1/4x minus 1/4 sine 2x plus 1/8x plus, you can actually simplify 1/8x and 1/4x. I just realized that. Okay, so 1/4 plus 1/8, you can rewrite 1/4 as 2/8. So basically 3/8, and then the 2 plus 1, 3. So here you can say 3/8x. I just, simplify these two terms, right? I will just show you here. So these two terms, 1/4x and 1/8x. So that's just 3/8, and then minus 1/4 sine 2x, and then plus 1/32 sine 4x plus c. Okay, so this is my second nasty integral today. Okay, not very friendly, but now you know how to tackle this. Okay, the next one, cosine squared theta. You can now pause the video and try this. I already did it, or somehow, using the cosine double angle identity, right? And replace cosine squared by, some term in cosine double the angle, and then just substitute with the upper term minus the lower term. So this is basically for you. You can try and let me know if you have any questions. Okay, let's have a look at this. 1 minus sine x over cosine x dx. So how to approach this? Now we have numerator and denominator, right? And usually, if you think about the len, right? So if you say, okay, so I have integration of 1/x dx is going to be ln of the absolute value of x, but in this case, I need to have the derivative of the denominator up. For more details about this, you may check my video, my first video, Nasty Integrals Part 1. I know I explained that in more details about how to do inspection, how to integrate by inspection. But here, even if you think of cosine, okay, you need to have the derivative up to say that it is the len, but you have 1 minus sine x. So in this case, we have to split this integration here. And we can split from the numerator. If you have the negative up, is fine. So this is going to be the integration of 1 over cosine x dx minus, okay, or we can say plus the integration of negative sine x over cosine x. Okay. Now you ask yourself, okay, what is the derivative of cosine x? D by dx, okay, derivative of sine, cosine. But derivative of cosine is negative sine. So derivative of cosine is negative sine. Again, this is very, very beautiful surprise. Why? Because negative sine x is up there. That means what? That means the integration by inspection right away, this part here is going to be the len of the absolute value of the denominator. Okay. Now we have another challenge now here, which is the integration of 1 over cosine, which is basically the integration of sec x dx. Integration of sec x dx. How we're gonna do that? So there is also like a famous manipulation. So integration of sec x dx, you multiply the numerator and denominator by sec plus tan. So you multiply both the numerator and the denominator by sec x plus tan x, and you will see why I did that. Still we have dx. And then let's expand. So this would be the integration of sec squared x, right, plus sec x tan x secant x multiplied by tangent of x, right? And all of this divided by sec secant of x plus tangent of x dx. So again, look at the denominator. So every time you have a function like ratio of two functions, you have to ask yourself one question: what is the derivative of the denominator? So let's find out. Let's find out the d by dx of secant x plus tan x, tangent of x. What is that? So look at your booklet. So you will find that the derivative of secant is secant times tan. And derivative of tangent is just secant squared x, which is exactly what we have at the numerator. So the numerator becomes now the derivative of the denominator. So the integration right away is len the denominator. Okay. So the integration now of secant of x is going to be ln the absolute value of secant x plus tangent of x. And we still have the second part, which is ln of cosine x. And then I will not forget the constant of the integration, because this is indefinite integral. So you always need to add the constant, the c. Okay. One more. Okay, one more nasty integral. Last one for today. Y plus 6 divided by 2y minus 1. This is really doesn't look like any of the forms in your booklet, right? Like, the arctan, for example, if you think, or I don't know, arc sine, but there is no square root, or arc cosine. So this is really, not very easy integral. So what we need to do some manipulation, algebraic manipulation, and then see how we can get from there. So what I would do, I would split from the top here. So this is, I can rewrite this as the integration of y over 2y minus 1, right, plus 6, okay, over 2y minus 1, right? I just split, so this is y divided by this whole denominator plus 6 divided by this whole denominator, and we still have dy. Okay, so I will deal with each one separately. So let's say, okay, so this is the integration of y over 2y minus 1. Now plus, okay, this is dy here, and then plus 6, I will take it out, and then we have dy over 2y minus 1. Now let's try to find the derivative of the denominator. Let's see if we can find, derivative of 2y is 2, and derivative of -1 is 0 because it is a constant. So we need just 2 up here, which is easy, right? So we can multiply by 2 and divide by 2, right? So we have integration of 2 dy divided by 2y minus 1. That is len the denominator right away. You have the derivative up. Okay, inspection. Okay, so this part here is done. So this part here, I will say, okay, so we have here 3, 6 over 2, 3 times len, the absolute value of 2y minus 1, and this part is done. Now let's look at the first part here. Oh, we have y, that's a problem. Okay. So what I would do, I would multiply the numerator by 2 and divide by 2. Okay, so I have 2y over 2y minus 1. I did not do anything. I did not change, right? I just multiply by 2 and divide by 2. And then I will subtract 1 at the numerator and then add it again. So I did not change the integration itself. And then I'm going to split this fraction here, from this plus here. So what I will end up with, I will end up with 1 over 2, the integration of 2y minus 1 over 2y minus 1 plus 1 over 2y minus 1, and all of this multiplied by dy. Okay. So what is 2y minus 1 over 2y minus 1? It is basically 1. So that will be 1/2 the integration of 1 dy. That is easy. And then plus 1/2 the integration of 1 over 2y minus 1 dy. Now I can integrate now 1 over 2y minus 1. Again, I will multiply by 2 and divide by 2. And then don't forget, we have here 3 ln of 2y minus 1, right? So we are almost there. So it's going to be 1 over 2, integration of 1 dy is y, and then plus 1 over 4, integration of 2 over 2y minus 1, derivative is up. So again, is it ln 1 over 4 ln the denominator 2y minus 1 plus 3 ln of 2y minus 1. So now we have two terms, similar terms, 3 plus 1 over 4. Okay, so 3 plus 4, 12, plus 1, 13. So basically 13 over 4. So the final answer is 1 over 2y plus 13 over 4 ln of the integration of 2y minus 1. And of course, don't forget to add the constant of the integration because this is indefinite integral. Okay, The full session for today, the full lecture of today, sorry, I should say that in the beginning, is for IB MAA high level. This is all of these questions, higher level. For SL, don't worry about them. So this is the level, I mean, expected. I mean, this is kind of, good questions, challenging questions, integration for higher level IB. Thanks for watching. Please feel free to leave comments, likes, subscribe, and have a nice day.